For Lesson 4.1 Skills Practice and 4.1 Practice, we're talking about graphing equations in slope-intercept form. And we know that slope-intercept form is one form of writing linear equations, and that looks like this: y equals mx plus b. So in 1 through 4, you're given the slope and the y-intercept, so you simply have to plug in the slope for the m value and the y-intercept for the b value. So for number 1, we have y equals 1/4 x plus 3. Go ahead and do the rest of those problems. For numbers 5 through 7, it says to write an equation in slope-intercept form. So again, we're looking to write it in y equals mx plus b form. And so we can see right here on number 6 that it crosses the y-axis at 2. So in our y equals mx plus b, it's going to be plus 2 at the end. Of course, we have our y equals and we have our x value. Now we just need to find that slope. There's a couple different ways to do that. If you have a graph like you do on 5 through 7, you can simply count up 1, 2, and then over 1, 2, 3, 4, 5. So the slope is 2/5. Okay, there is another way to do that. If you're given 2 points, which we're given here, 0, 2, and -5, 0, we can find the difference in the y values. 2 minus 0 is 2, and then the difference in the x values. 0 minus a -5 is 5. So we get the same answer whether we count up and over on a graph or use our y minus y over x minus x little formula, or we can also refer to that as our rise over run. Please do number 6 and 7. For number 8 through 10, it says to graph. And remember, in slope-intercept form, it's very easy to graph by starting with the y-intercept. So up 2 and put a dot. And then the slope is a -1/2. It doesn't matter if the 1 is negative or the 2 is negative, but they both can't be negative, otherwise it's a positive. So from this point right here, we're going to go up 1 to the left 2, or we're going to go down 1 and to the right 2. Either way, you're fine. Make sure that you connect those points with a nice long line with arrows at both ends. Please do number 9 and 10. And for number 11, we have a story problem. I would like for you to try that one as well. When I look at skills practice 4.1, we have the same types of equations or same types of problems where you're writing an equation in slope-intercept form. So you should be able to do 2, 4, 6, and 8 on that skills practice. And then same thing, 9, 10, and 11, 12, 13, 14. I'd actually like you to do the rest of those because you can't ever get enough practice graphing. So please do 2 through 8 evens and then 9 through 15 all. For Worksheet 4.2, Study Guide and Intervention, you're going to be writing equations in slope-intercept form, and you're going to be given a point on the line as well as a slope. There's 2 examples right there for you to look through. I'm also going to work out 3 problems on this. I would like for you to do all the problems 1 through 12 on this worksheet. So on number 1, actually for all of these problems, we're always going to be thinking about that y equals mx plus b slope-intercept format. Okay, and what we're given on number 1 is the m, the slope value, and then we're given an ordered pair. And remember that ordered pairs are always in the format of the x value or x coordinate first and then the y value. So we are given a y value, an x value, and an m value so that we can solve for that b value. So this is how it works. I'm going to start by writing y equals mx plus b. Underneath the y, I'm going to put the 5 because the y is the 5 value there, equals, the m value is 2, so I'll substitute that in. The x value is 3, so I'll substitute that in, and then plus b. If I simplify, I get 5 equals 6 plus b, and then if I minus 6, I get -1 equals b. And you can see right here that it crosses at -1, but just to make sure, we solve that algebraically by solving for b, and so my final answer for number 1 is y equals 2x. I'll substitute that m value back in for 2, or for m, and then substitute in my b value, which is -1. Okay, let's take a look at number 5. Number 5 does not have a graph, it just tells you the ordered pair and the slope. I'm going to do it the same exact way though as number 1, y equals mx plus b. For my y value, I'm going to put in -3, and for my m value, I'm going to put in 5. For my x value, -1, and then plus b. I get -3 equals -5 plus b. When I add 5 to both sides, I isolate my variable b and get -3 plus 5, which is 2. My final equation then is y equals 5x plus 2. Finally, for number 7, you might be thinking there's a shortcut, and there is, because we know that a slope of 0 is a horizontal line. So if here is a coordinate plane and I go -5 up 4, a horizontal line is going to be y equals 4. But let's just say you didn't know that shortcut and you couldn't remember if a 0 slope was a horizontal or vertical line. We can still use that same process that I showed on 1 and 5. Okay, so I'm going to go here and put y equals mx plus b, and then my y value is equal to 4. And so I'll say 4 equals 0x, and my x value is -5 plus b. So 4 equals 0 plus b, or 4 is equal to my b value. And so it crosses the y-axis at +4, and my final equation is simply y equals 4. Because if I substitute that 0 back in for x, 0 times x is 0. So that's the final equation. Like I said, please do all the problems 1 through 12 on this worksheet. For worksheet 4.3, we're talking about writing equations in point-slope form, and we briefly touched on that at our Pi Day seminar, and that format is y minus y1 equals m parentheses x minus x1. And just to review, slope-intercept form is y equals mx plus b, and standard form is ax plus by equals c. In all situations, x is to the first power, making them all linear equations, so that when we graph them, we get lines. This worksheet just happens to focus on point-slope form, and all we're going to do is plug in our x and y value and our m value, and it's pretty easy. So for 1 through 6, I'd like for you to do all of those. We're going to substitute in the 2 for the y value, and then the -3 for the m value, and then x minus 2. Okay, I'll do one more. For number 3, the format is y minus y, but if our y is a negative number, it's going to turn into plus. So it's going to be y plus 4 equals, the slope is 0, okay, and then we're going to plug in x plus 3 because it's a negative value. Okay, so what happens here is 0 times anything is 0, taking away everything on the right side, and we get y plus 4 equals 0. And when we subtract 4 from both sides, we get that y equals -4, which in fact it is right here, a horizontal line at -4 with a 0 slope. Okay, please do 1 through 6, substituting in that y1 value and x1 value, and of course the m value, the slope. For problems 7 through 15, you're going to write those equations in standard form. So in order to write them in standard form, which again is ax plus by equals c, we have to first of all distribute the number outside of the parentheses, in this case the 3, so we have y minus 11 equals 3x minus 6. That's pretty straightforward. Now I want to get the x and the y on the same side. So I'm going to minus 3x from both sides, and I will get negative 11 plus y minus 3x equals negative 6. You might want to cut corners here and actually just add 11 to both sides on that same step. You're going to get the same answer, but I'm going to take this down to my space by 13 so I can finish the problem here. When I subtracted 3x, I get negative 3x. The y is positive, there's no positive sign there, but I need to have a symbol in between the x and the y, and then equals. And what I have here is a negative 6 plus 11, so that's equal to 5. So there's my equation for number 7 in standard form. Let's try one more of those. Let's go over to number 12. I'm going to start by distributing the 4/3. So I get y minus 6 equals 4/3 x minus, don't forget when you take 4/3 times 3, it's like 4/3 times 3 over 1, and the 3's cancel out, and so I get minus 4. Okay, I want to get the x on the same side as the y, so I'm going to minus 4/3 x minus 4/3 x, and I'm going to plus 6 to get that on the right hand side. So what I have is a negative 4/3 x, and then when I have the y there, it's a plus y. Remember, there's no symbol right here in front of the y, so it's a positive. And then equals negative 4 plus 6, which is plus 2. Now, what you can do when you have a fraction as a coefficient of your x value, you can multiply everything by the denominator, so you have just integers there. So what we would get here is negative 4x plus 3y equals 6. So just a side note on those. And then finally at the bottom here we have 16 through 21, again written in point slope form, but we're going to write it in slope intercept form, which is y equals mx plus b. Okay, so for number 18, negative 5 times x and negative 5 times 12 are still going to start the same way. Y minus 3 equals negative 5x minus 60. And in order to get y by itself in this one, all I have to do is add 3 to both sides. And I'm left with y on the left, y equals, and then negative 5x minus 57. So there's my final answer for number 18. For number 19, we have a fraction that we need to distribute, and don't let that scare you, we can still work with it. We have y minus 5 equals 3 halves x, and remember 4 is over 1, so we have 3 times 4 is 12, 12 over 2 is plus 6. And so we're just going to add 5 to both sides, and we get y equals 3 halves x plus 11. Okay, go ahead and do all the problems on worksheet 4.3, practice writing equations in point slope form, and also going between point slope and standard form and slope intercept form. For worksheet 4.4 practice and skills practice, we're talking about parallel and perpendicular lines. And if you haven't already watched the Ed puzzle about parallel and perpendicular lines, I suggest you do so because that provides you with some basic background information. When we're talking about parallel lines, we have lines that will never intersect or have 0 solutions because they never cross. But it's also important to recognize that the rise over the run, the slope, is going to be the same in both of those lines, and so parallel lines have the same slope. Okay, perpendicular lines meet at 90 degrees. Okay, and so when we take the slopes of perpendicular lines, we get a product of -1. And what that means is that the slope of one line, let's say that's -2, the perpendicular line to that -2 slope is a positive 1/2. It's not only the reciprocal, but it's also the opposite. And when I take -2 times 1/2, I get that -1 value. And that's what we're going to be working on with these two worksheets. So I'll do quite a few problems here with you to get you started, and then I will be assigning some problems for you to do independently. So number 1 asks to write another equation that is parallel. So parallel lines have the same slope. So the one that's given to me here is y equals x plus 5. So my other equation has to have the same slope. In this case, the same slope as what's given is a 1. So I'll go off to the side here and write y equals mx plus b. And similar to the worksheet 4.1, we're going to substitute in the x value and the y value and solve for b. So the y value is 2. The m is the same slope as what's given, so I'm going to put a 1 in. And my x value is 3, and then plus b. So we get 2 equals 3 plus b minus 3 minus 3. -1 is my b value. So the equation that's parallel to y equals x plus 5 is y equals x minus 1. Of course, there's lots of parallel lines to that equation, but if it has to pass through that ordered pair 3, 2, then this is the one it's going to be. For number 6, let me go ahead and jump over here to number 6. Number 6 is written in standard form, and so it does say to write in slope-intercept form, so I'm going to change that by subtracting 2x from both sides, and I get y equals -2x plus 5. Sorry, that looks like a division sign right there. I don't want that to be there. Just minus 2x from both sides to get it in slope-intercept. Now, the slope of this line given is -2. So if I'm going to write an equation that's parallel to the given equation and it also goes through that point, I'm going to start with y equals mx plus b. For the y value, I'm going to put in what's given, which is 1. My m value is the same as the other equation, so -2. My x value is 3, and then plus b. So we get 1 equals -6 plus b. Add 6 to both sides, 7 equals b. So my final equation that is parallel to the one given and passes through that point is y equals -2x plus 7. One more, and then I'd like for you to finish all of the odd problems, 1 through 12 odd. 1 through 12 odd. Okay, so let's look at number 8. Number 8 is also in standard form, so I'm going to subtract 3x from both sides to get the x on the other side. So we have -y equals -3x plus 5. I don't like the -y, so I'm going to divide everything by a -1. So I get y equals -3 divided by -1 is a positive 3x, and then 5 divided by -1 is -5. So that was a little bit trickier because we had to change it into slope-intercept and we had to divide by -1 because of that negative coefficient of the y. Okay, so now we know that the line parallel to this line right here is going to have the same slope and pass through this point by, go ahead and write y equals mx plus b. For my y value, I'll put in -2. For my m value, it's 3. X value is -1, and then plus 6. So we get -2 equals -3 plus 6. When you add 3 to both sides, we get 1 equals b. So the final equation for the line that's parallel to this one and passes through that point is y equals 3x plus 1. Try the rest of those 1 through 12, 1 through 11 odd, and let me know if you have any questions. For 13 through 24, I'd like for you to continue. Let's just go ahead and do 13 through 23 odd. Gives you some more practice there. And then it says, this time to find the one that's perpendicular to the graph. Okay, so for number 13, we have a slope of -1/3. The opposite reciprocal would make it a positive, and the reciprocal of 1/3 would be 3. So the slope of my perpendicular line will have a value of 3. So we go y equals mx plus b. My y value and my x value are the same, so that's going to look -2 equals 3 times -2 plus b. -2 equals -6 plus b. Add 6, add 6, 4 equals b. The final equation for number 13 is y equals 3x plus 4. Let's do another one. Number 18 gives us an equation in standard form. Okay, so the first thing we're going to do is get that into slope-intercept by subtracting 3x from both sides. We get 12y equals -3x minus 6. Divide by 12, divide by 12. Y equals -1/4 x minus 1/2. All I really care about is that slope, because for perpendicular lines we have the opposite reciprocal, or the value that's going to make -1/4 equal to -1. So the opposite would be a positive, and the reciprocal of 1/4 would be 4. So my slope for my perpendicular line is going to be 4. So y equals mx plus b. My y value here is -5. So, whoops, wrong one, sorry. My y value is -7. -7 equals 4 times my x value is -1 plus b. -7 equals -4 plus b. Add 4, -3 equals b. That's just my y-intercept. So my final equation is y equals 4x minus 3. You might want to work out these problems on a separate piece of paper just to show all of those steps, and make sure that you understand that the parallel lines have the same slope, and you're just plugging in that y and x value to find the b value. And for perpendicular lines, you're finding the slope but then finding the opposite reciprocal for the other line to solve for the b value. So quite a bit of things going on there. I'd like for you to do 1 through 11 odd, and then 13 through 23 odd. So essentially 1 through 23 odd. And then coming down to your skills practice, this worksheet I'd like for you to try 2 through 18, okay? 2 through 18, same exact problems as the other worksheet, but the more you do that, the more practice you'll get with operations with negative numbers and integers and rational numbers, and moving around the equations in slope-intercept, standard form, and so forth. So I think you're going to really feel confident about your skills in parallel and perpendicular lines after completing this worksheet. For worksheet 5.1 skills practice, we're solving inequalities by addition and subtraction. And just notice that there's one variable. In the next lesson we're going to have two variables, but when we have one variable inequalities, we're going to treat that much like an equation and isolate the variable by doing the opposite operation. So we're just going to subtract 11 from both sides and get x is greater than 5. And remember, with our greater than and less than signs, we have an open circle. Our greater than and less than or equal to signs, we have a closed circle. So we're looking for an open circle at the number 5 with an arrow going to the right. And that is number or letter C right here. So number 1 is letter C. Go ahead and finish 2, 3, 4, and 5. And then come down here to 6 through 13 and do these the same exact way. I'll just pick one to do here. I'm going to pick number 10 because it has the variable on the right side. I'm still going to isolate the k by subtracting 3, and then I get 1 is greater than or equal to k. I like to have the variable on the left-hand side, so I'm going to rewrite that as k, but then I'm going to flip the inequality sign and put k is less than or equal to 1. So that's a closed circle at the number 1 with an arrow going to the left. At the bottom of the worksheet, it has some sentences for you to translate into a inequality. So a number, so that can be any variable you want. I'm going to choose x, decreased by 10. So x decreased by 10, greater than, and then negative 5. Notice it does say to solve as well. So I'm going to add 10 to both sides and get x is greater than 5. It does say to check your solution, so I'm going to pick a number greater than 5, like number 6. So is 6 minus 10, I'm going to substitute it back into the original inequality. Is 6 minus 10 greater than negative 5? Yes, negative 4 is greater than negative 5, and that works out. On this worksheet, I'd like for you to do all of them 1 through 18. For Lesson 6.1 Skills Practice, we're graphing systems of equations, and there's a lot going on here on 1 through 4, so not that that's not important. I just want to make sure that you understand how to graph. So I'm going to skip down to number 5, 6, and 7. Those will all be due on this worksheet. I'll do number 5, and then you can do 6, 7, 8, and 9 for homework. So for number 5, we're going to graph these and then determine if it has solutions. And if there is one, name it. So for number 5, there are 2 equations, both written in standard form. So depending on what you want to do, you can substitute in 0 for x and 0 for y and find the x and y intercepts, or you could subtract 3x from both sides and get both of the equations in slope-intercept form. So if I subtract 3x from both sides, I get negative y equals negative 3x minus 2. And if I divide by negative 1, because I don't want to know what a negative y is, I get y equals, and then negative 3 divided by negative 1 is 3. X, and then negative 2 divided by negative 1 is positive 2. So y equals 3x plus 2. So I go up 2 on my y-axis and plot my point. I can go up 3 over 1, or I can go down 3 over 1. I'm going to do that since there's room for it, and then connect those with a line. Okay. Now what I'm trying to do when I'm solving a system of equations by graphing is to see whether or not those lines intersect. So I could have parallel lines and then there's 0 solution. I could have 2 lines that intersect, so that would be 1 solution, and I could have the same line on top of it, and that could be infinitely many solutions. So let's see how this next one comes out. We're going to subtract 3x from both sides and get negative y equals negative 3x plus 0. Again, I don't want to know what a negative y is, so I'll divide by negative 1, and I get y equals 3x. There's no y-intercept, so that will be the point 0, 0, and then the slope is 3. So up 3 over 1, or down 3 to the left 1, we have the same slope, and therefore we have parallel lines on number 5, so they will not intersect. There are 0 solutions. So hopefully you have a straight edge and you can draw a straighter line than I did on that one, but go ahead and try 6 and 7 on your own and let me know if you have a problem. I'll do one of these story problems. I'll do number 9. It says a used bookstore started selling used CDs and videos, and in the first week they sold 40 used CDs and videos. So I'm going to start with x equals my CDs and y equals my videos. So letter A says to write a system. Well, the first equation is x plus y equals 40 because I sold 40 of them. And then it says $4 per CD, so that's 4 times x, $6 per CD plus 6y, and they sold $180. Okay, so that's my second equation in my system. Okay, it says to graph it. Since they're both in standard form, I'm going to choose to do my x and y intercepts. So I'll plug in 0 for x and y. If 0 is x right here, then my y is 40. And if my y is 0, then my x is 40. So that's my x-intercept, and there's my y-intercept. So hopefully, again, you have a straight edge that you can connect those two points straighter than what I'm going to be able to do right here. But when you're trying to find a solution where they cross, it's really important to have straight lines and points to look at. For the second equation, I can plug in 0 for x, and that gives me 6y equals 180, so x or y is equal to 30. And if I plug in 0 for y, I get 4x equals 180. 180 divided by 4 is 45. So 0, 30 is right here on the y-axis, and 45, 0 is right there. And if I connect those 2 points with a line, I can't tell exactly where they cross. Is it 20, 20? Well, let's just double check by plugging that in. Does 20 plus 20 equal 40? Yes, it does. 4 times 20 is 80. 6 times 20 is 120. And 120 plus 80 is not 180. So I need to have another strategy for solving these types of equations if I don't find that exact point where they cross. And so what I can do is something called substitution. This first equation, x plus y equals 40, I'm going to write that as minus x, y equals 40 minus x. And then what I can do is I can plug in 40 minus x for y in my second equation. 4x plus 6y is 40 minus x. And then that's equal to $180. 4x plus 240 minus 6x equals 180. When I subtract 240 from 180, I get negative 2x equals negative 60. And when I divide by negative 2, negative 60 divided by negative 2 is a positive 30. So x equals positive 30, which means y would equal 10. Let's just check that. Does x plus y equal 40? 30 plus 10 equals 40. Let's plug that in over here. 4 times x value, 4 times 30 is 120, plus 6 times y, 6 times 10 is 60. 120 plus 60 is equal to 180. So the solution to that system is 30-10, which means that they sold 30 CDs and 10 videos. Does not look like that's where they crossed on my graph, but again, it's importance of using a straight edge so you can make sure that you find the exact point where they cross. We also used another method called substitution to verify that. So for lesson 5-6 practice, we're going to be graphing inequalities with 2 variables. So it's going to be a little bit different than what we were doing before. So we have x plus 3 is greater than 7, minus 3, x is greater than 4. Now we have 2 variables, just like we do when we're graphing equations like y equals 3x minus 2 or 3x plus 2y equals 6. So this is going to be a little bit tougher since we really didn't go over this, but Pay attention to the examples that I show you and then try a few on your own. So for 1 through 3, I'd like for you to do all of those. I'll do number 1 for you right now. 3x plus y is greater than or equal to 6. Does 4, 3 make that inequality true? Well, 3x would be 3 times 4 plus y, which is 3, is greater than or equal to 6. That's 12 plus 3 greater than or equal to 6. Yes, 15 is greater than or equal to 6. So that is a solution. Okay, for negative 2, 4, we're going to plug in negative 2 for x. So 3 times negative 2 plus y, which is 4. And then, I don't know why I just put that there, greater than or equal to 6. So 3 times negative 2 is negative 6 plus 4 greater than or equal to 6. Negative 2 is not greater than or equal to 6. So negative 2, 4 is not a solution. Negative 5, negative 3, we have 3 parentheses, negative 5 plus y, negative 3, greater than or equal to 6. That's negative 15 plus negative 3, which is not greater than or equal to 6. So that is not a solution. And finally, 3 times 3 plus negative 3, greater than or equal to 6. 3 times 3 is 9. 9 plus negative 3 is equal to 6. So yes, this is a solution. So this one, the first and the last ordered pair. Try number 2 by substituting in, again, those x and y values for x and y in your equation and seeing if it's true. So 1 through 3, do all. And then through 4 through 9, I'm just going to have you do a couple here. This is, again, something we did not talk about, but you're capable of doing it using what you already know about some other things. First of all, 2y minus x is less than negative 4 is not really in it's not in slope-intercept form, and it's not technically in standard form because it has the y and the x reversed. But we can easily turn that into slope-intercept by adding x on both sides. So we get y equals x minus 4, and it's actually 2y equals x minus 4. And then we're going to divide by 2. Oops. Divide by 2, and get y equals 1/2 x minus 2. And it's not even equals, it's less than. So I've already messed up and hopefully not confused you. But same as before, we're going to put it into a format that we want to work with. Okay, so I'm going to go down 2 and put a dot, and then 1/2 is our slope, so up 1 over 2, up 1 over 2. Now, remember how less than and greater than were an open circle, and less than or equal to and greater than or equal to were closed circle? Well, when we're graphing inequalities, that open circle is going to translate to a dotted line, and the solid filled in circle is going to translate to a solid sign. So since this is less than, we're going to use a dotted line to connect those points. And then since it's less than, we're going to shade, all the parts down here, because all of these ordered pairs are solutions to that inequality. And just to make sure, you can always test a point. For example, the point 0, 0 is not on the line. So let's plug that in. Plug 0 in for x and 0 in for y. So we get 2 times 0 minus 0 is less than negative 4. 2 times 0 is 0. 0 minus 0 is 0. Is 0 less than negative 4? No, it's not. That's why I did not shade in this direction up here. I shaded in the other direction. Okay? Again, that's the first time of hearing that kind of a problem, so don't freak out. Just stay tuned and we'll do a couple more and then you can try the others. Okay? Let's do number 6. Okay? It's almost in slope-intercept form, so I'm going to divide by 3, and get y is greater than 2/3 x minus 1. Remember that when you divide by 3 in the denominator there, that you have to take both the 2x divided by 3 and the negative 3 divided by 3. So I'm going to go down 1 and put a dot, and the slope is up 2 over 3. So put a dot there. You could also go down 2 to the left 3. Okay, it is a greater than sign right there. So we are going to connect those 2 points with a dotted line. Okay, and since it's greater than, we're going to shade in this portion of our graph. And you might say, why? Well, if I pick any point, I'm going to pick 0, 0 because it's the easiest one to work with, and I plug 0, 0 in for x and for y, I get 3 times 0 is greater than, whoops, let me move that out of the way, is greater than 2 times 0 minus 3. 3 times 0 is 0. 0 is greater than negative 3. 2 times 0 is 0. Then there's negative 3. 0 is greater than negative 3. So because that point worked, that's the part I want to shade. On number 4, that point didn't work, so I wanted to shade in the opposite direction. Okay, I'm going to do one more. I'm going to have you try 3 by yourself. Okay, so we are going to, on number 7, get rid of the negative 6 by minusing 6. So I get 0 is greater than 2/3 x minus 1. Now you're really going to be thrown for a loop because I'm going to change that 0 into y and write that as y is greater than 2/3 x minus 1. Okay, so on number 9 you're going to minus 1/2 and get y is greater than negative 2x plus 7/2 minus 1/2 is 6/2, which is 3. So try to do that number 9 on your own. And on number 7, when you add 5 to both sides, we get y equals, not equals, less than or equal to x minus 4. Okay, so try to do that one. I'll finish this one that I just did. On number 8, negative 1 is my y-intercept. Plot that point. 2/3 is up 2 over 3 or down 2 to the left 3. It's a greater than sign, so I'm going to connect those with a dotted line. And it's greater than, so I'm going to shade in this direction. And just to prove it, I'm going to pick the point 0, 0, which is on the upper side of that line, and plug it in here. So 0 is y, greater than 2/3 of 0 is 0. 0 minus 1 is negative 1. Is 0 greater than negative 1? Yes, it is. So you want to shade on that side. Try to do problems 5, 7, and 9, as well as 2 and 3 on this worksheet. If you have any questions, let me know. For Worksheet 6.3 practice, you're going to be solving systems of equations using elimination that have addition and subtraction. I know that was kind of a mouthful, but just to refresh your memory, we did talk about solving system of equations in Chapter 9, and we graphed 2 equations on a coordinate plane, and we saw exactly where those 2 lines crossed, and it had one solution. Sometimes systems, though, are parallel and they have 0 solutions because they're never going to cross, and sometimes you graph the same line on top of each other and you see that it's going to have infinitely many solutions. Well, you don't always have graph paper handy, and those points where they cross aren't always at exact integers, so we have to have other strategies to use. And this strategy is called elimination, and you do that by either adding or subtracting the equations. Let me demonstrate. I am going to add these 2 equations together. What's 1x plus 1x? We get 2x. What's negative y plus positive y? That's 0, hence the name or strategy elimination. We're eliminating the y's so we can solve for x. What's 1 plus negative 9? That's negative 8. And then when we divide by 2, we find out that x is equal to negative 4. Once we know what x is, we can plug that back into our equation and find out what y is. You can actually use either equation, it doesn't matter. So I have x plus y equals negative 9. That's the second equation. And if I plug in negative 4 plus y equals negative 9, I find out that y is equal to negative 5. So the solution to the system of equations for number 1 is negative 4, negative 5. That's where those 2 points or 2 lines cross if we were to graph them. I'm going to jump over here to number 5. This one, you'll notice that both of my y's are a positive 2y, so instead of adding these together, I'm going to subtract them. So 3x minus 4x is negative 1x. 2y minus 2y is 0, therefore eliminating it. And then negative 1 take away 6 is negative 7. You have to kind of be careful with the subtraction ones because if you get two negatives, obviously that turns into a positive. So in number 5, x is equal to 7. Well, if x is 7, I can either substitute it into the top equation or the bottom. It doesn't matter. So I'm going to do 3 times x, which is 7, plus 2y equals negative 1. That's 21 plus 2y equals negative 1. Subtract 21, subtract 21, 2y equals negative 22. Divide by 2, divide by 2, y equals negative 11. So we would say the solution to the system of equations is 7, negative 11. That's where those 2 lines cross. 7 and negative 11 also make both of those equations true if we would substitute them in. I'm going to do one more and I'm going to assign some for you to try on your own. Number 15. Number 15, it's easy to see that we have 2 ends with the same coefficient, negative 8. So if I added those together, I'd get negative 8n plus negative 8n, which is negative 16n. And that's not going to be what we want to do because I'm not going to eliminate it. I want to subtract those two, so I get negative 8n take away a negative 8n, which is negative 8n plus 8n, which is 0, therefore eliminating it. So 6m minus 2m is 4m. 3 take away a negative 3 is a positive 6. So 4m equals 6. Divide by 4, divide by 4. M equals 3/2 when I reduce. Okay, so I'm going to use the second equation here to substitute in my m value. So I get 2 times m, which is 3/2, minus 8n equals negative 3. 2 times 3/2 is 3 because the 2's cancel each other out. So 3 minus 8n equals negative 3. Subtract 3 from both sides, we get negative 8n equals negative 6. Divide by negative 8, divide by negative 8, n equals positive 3/4. Okay, that wasn't as nice with those fractions in there, but it's still possible. Again, if you think about graphing those, would you have been able to tell exactly that point where they crossed if they crossed at 1.5 3/4? Probably not. That's why we have to have another strategy to use. So the system of equations for number 15 has a solution of 3/2, comma, 3/4, okay, and that's the ordered pair where they cross. There are 23 problems on this page. I'd like for you to pick 5 on 1 through 18 to try on your own. So pick 5 from 1 through 18. Okay, let's scroll down to the bottom here and take a look at number 19, a story problem. I'd like for you to try one more story problem down here on your own. Pick one. Obviously don't pick number 19 because I'm working it out for you. So the sum of two numbers is 41, so x plus y equals 41, and then their difference is 5, so x minus 5, oops, not that way, x plus y equals 41, and x minus y equals 5, okay? This lends itself to adding because positive y plus negative y is 0. So 1x plus 1x is 2x. let me come over here, 2x equals 41 plus 5 is 46. Divide by 2, divide by 2, x is equal to 23. And if x is 23, then y has to be 41 minus 23, which is 18. So x is 23, y is 18. 23 minus 18 is 5, okay? And 23 plus 18 is 41. Now, could you have solved that system of equations mentally? Absolutely. But I want you to get in the practice of writing equations and substituting in values and solving systems using this new strategy. So pick one from 20, 21, 22, or 23, and then pick 5 from the top, 1 through 18, not the ones I already did with you. For worksheet 6.4 skills practice, we're still going to be looking at elimination as a strategy for solving a system of equations, but this time we're going to have to use multiplication so that we can in fact cancel it out. So on number 2 here, we have 3x and 2y equaling negative 9, and since the x doesn't have a 3 coefficient and the y doesn't have a 2 coefficient, I can't immediately add or subtract. I have to multiply one of the equations, in this case the bottom equation, by one of the coefficients of x or y so that I can eliminate it. I'm just going to choose my 3 for my x value and multiply everything by 3 in the bottom equation, and make sure you distribute that x or that number 3 to everything in the parentheses. So I get 3x plus 2y equals negative 9. And when I distribute the 3 on the denominator or on the bottom part, I do 3 times x, which is 3x, 3 times negative y, which is minus 3y, and 3 times negative 13, which is negative 39. Okay? And now I have the same coefficient for my x's, so I can subtract it and eliminate the x's. So 3x minus 3x is 0. Okay? Then I have 2y, take away a negative 3y, which is a positive 5y. And I have negative 9, take away a negative 39, which is negative 9 plus 39, which is 30. When I divide by 5, I get y is equal to 6. And I can plug that 6 back in for the y in the first equation or the second equation. I'm going to choose the second equation, which is x minus y equals negative 13. X minus 6 equals negative 13. Add 6 to both sides, and we get x is equal to negative 7. So the solution to this system of equations is negative 7, 6. If you were to graph that system right there, they would cross at negative 7, 6. I'm going to try one more here, and I'm going to have you try some on your own. Okay, look at number 8. Number 8, again, does not have any coefficients that match up, so we can just right away add or subtract. We have to multiply. And in this case, we're going to have to multiply both equations by something to get a variable to be eliminated. It doesn't matter if you pick the x's or the y's. Okay, I'm going to choose the x's here, and I'm going to multiply by 3 on the first equation, so I get 6x plus 9y equals 42. On the second equation, I'm going to multiply by 2 so that I get 6x minus 8y equals 8. Why did I choose the 3 and the 2? Well, 3 times 2 is 6, and 2 times 3 is 6. If I wanted to eliminate the y's, I would multiply the first one by a 4 to get positive 12, and I'd multiply the bottom one by 3 to get a negative 12. Okay, so in this case I did the x's, I multiplied, and I am going to subtract, so I get 6x minus 6x, which is 0, I eliminated it, 9y, take away a negative 8y, which is 9y plus 8y, which is 17y. And then 42 minus 8 is 34. divide by 17, divide by 17, y is equal to 2. If y is 2, I can plug it back into either equation for y. I'm going to choose the first one. So that's 2x plus 3y, y is 2, equals 14. And then 2x plus 6 equals 14, minus 6, 2x equals 8. Divide by 2, x equals 4. So the solution to the system of equations for number 8 is 4, 2. The ordered pair 4, 2 satisfies both equations, and that's where they would cross. Okay? I would like for you to try 4 problems on here. I realize this is a skill that we haven't had much practice on, but you do know the components on how to get there. It's just going to take some time and some patience. So pick 4, obviously not the 2 that I've already done, but pick 4 on the sheet to complete. You might want to use a separate piece of paper since they do tend to take up a lot of space. So let me know if you have any questions about elimination using multiplication.